Welcome to the course on design and analysis of algorithms. I am DM Padulkar from RCID 1015, Vidya Patishthan College of Engineering, Baramati. Today we will be discussing a problem on finding a cycle in a circular linked list. So the problem statement is given a circular linked list in which a last node is pointing to the any intermediate node. Generally, the last node points to the first node, right? So our main objective is to detect a cycle, then find a cycle length, and the third one is find a starting node of a cycle. So to achieve the above objectives, we will consider a simple example as A gives A to B to C to D to E to F, in which a last node is pointing to the any intermediate node, let us say D in this example. To achieve the above objectives, we will have two different pointers P1 and P2. The task of these two pointers is, first of all, they are pointing to the first node, that is what A, let us say P2 and P1, they are pointing to the A, that is what starting node. P1 is a slower pointer and P2 is a faster pointer. P1 is slower pointer means it increments by 1, and P2 is faster means it increments by 2. Based upon this terminology, I will say P1 and P2 they meet at some node if there is a cycle. Okay. We will check whether we achieve the same thing in this or not. At this start, P1, P2 both are pointing to the A. I am going to enhance P1 by 1 and P2 by 2. So P1 is pointing to, or my P2 is pointing to 1, 2, means P2 is pointing to this node, am I right? And where the P1 will be? So P1 will be at B, am I right? Then again I am going to enhance this by 2, so this is P2 is going to point to the E, am I right? And this P1 is pointing over here. Then by the next step, this P2 is pointing to D, and P1 is also pointing to D. Its meaning is both the pointers P1 and P2, one is slower, another is faster, they are meeting at one of the point, it means there is a cycle. So our first objective was detecting a cycle, that was achieved, cycle is identified. So now we will move on to the next objective, and that is what? Find a cycle length. Okay. To find out a cycle length, one more thing that we will consider, that is we will take one counter, we call it as C. Okay. Whenever P1 and P2 they are going to meet each other, P1 and P2 they are meeting at D. As they are meeting, stop a faster pointer there and go on incrementing pointer P1. As we are enhancing pointer P1, that is what a slow pointer, by the same time increment a counter by 1, right. So here next step P1 is pointing over here, then counter is going to become 1, then P1 is pointing over here, the counter is going to become 2, and at last once again P1 is going back to the D, then counter is going to become 3. Then we will identify as the last value of C is 3, counter value is 3. Now we will check, is it really cycle length equal to 3? 1, 2 and 3 means correctly we have identified a cycle length. Still now we have achieved two different objectives. The first objective was detecting a cycle, second objective was of finding a length, and our last objective is to find out a starting node of a cycle. Okay? Now, earlier two objectives which we have achieved, just I will rewrite. We have identified a cycle, and second thing we have identified cycle length. Am I right? Now we will be moving on achieving the third objective, that is starting node of a cycle. Am I right? To identify starting node of a cycle, that is my third objective. What we do? To achieve this third objective, similar kind of the or same example once again I am going to continue. A, B, C, D, E and finally F, which is pointing to the D. Now, in order to achieve the third objective, I am changing my way slightly. How am I going to change the way? The pointers P1 and P2, I am going to increment these two pointers by same span. Like previous, I am not going to, one is faster, one is slower. Right now, I am considering these two pointers or enhancement in these two pointers is equal. I am not going to change it. But I am doing one more addition, and that addition is P1 is pointing to the starting vertex, P1 is pointing to the starting vertex and P2 is pointing to the node equal to the cycle length. What was the cycle length we have identified? Cycle length was 3. So, 1, 2, 3 means P2 is pointing to the D, right, and then we will enhance these two pointers with a equal span. Okay. By the next moment, this P1 is pointing to this, P2 is going to point to this, P1 will be here by the next movement, by the same movement P2 will be over here, then by the next movement P1 will be here and immediate next movement P2 will be here, means again they are meeting at the point, but the convention now is different. That convention is enhancing the pointer with the equal length and they are meeting, and at which node they are meeting is a node which is a starting node of the cycle, which is a starting node of the cycle. Just you can observe this from this point to this node to this, as we are moving step by step we are moving, and as we will be at a D and coming back at a D, right, means what, a sequential movement is going to end at D and again I am going to coming back to the D over here, right. It means D is a starting vertex of a cycle. Okay. So now the specified objectives, finding a cycle length, and the last objective that is of finding the starting vertex of a list, sorry, starting vertex of a cycle. We have identified this. Now, based upon this, we will move on to the correctness of this algorithm. In order to show the correctness of this algorithm, we will consider a cycle. Up to this point, it has travelled a distance x, am I right? Then they are meeting at point y, but there is one more pointer, that is what a slower pointer is coming back and meeting at that point. So, here it covers again some distance as z, am I right? So, now based upon this, we will consider pointer P1 travels a distance d, by the same time pointer P2 travels a distance 2d. That is our, in our first objective we assumed this thing, am I right? Okay. So, now I will write this d is equal to, what is distance travelled, that is what, x plus y, they are meeting at y. Then, but who is faster one is again coming back, means few more distance it is travelling. So, it is 2d is equal to, 2d is equal to x plus y plus this z, am I right? Is it only this thing? It is not a this thing, again they are meeting at point y na, so that the distance y is also we are going to add one more time, getting me, it is coming back to that. Okay. So, now these two things we have identified, d is equal to x plus y and 2d is equal to x plus 2y plus z. Are you agree with me? Now, so what the value of d we will put over here, 2 into bracket x plus y is equal to x plus 2y plus z. We solve this, 2x plus 2y is equal to x plus 2y plus z, 2y get cancelled. From this side x is remaining, from this side z is remaining, means we have proved, right, x is equal to z. So, we proved this, getting me? Okay. Now, based upon this, we will try to write some algorithm. Okay. First of all, algorithm for finding a cycle or checking there is a cycle or not. Okay. So, I will write algorithm name as a cycle, to which I am going to pass on a circular linked list, am I right? At the start, both P1 and P2 they are pointing to the starting vertex. Later on, P1 we are going to enhance by 1 and P2 we are enhancing by 2, am I right? Okay. Then somehow this P1 pointing to some node and P2 pointing to some another node, they are going to become equal, they are pointing to the same node, they are pointing to the same node. Then we are identifying, or then we are assuming, or then we are considering there is a cycle. Then second thing, that is what, finding a cycle length, finding a cycle length. To find out the cycle length, I have told we will stop the faster pointer and we will continue the slower pointer till it come back to the pointer P2. Am I right? So here my second algorithm, I will write algorithm 2, which is going to find out a length in a circular linked list. To find out this circular length of the cycle, so what I am going to stop? I am going to stop P2 pointer and I am going to continue enhancing the pointer P1 till it meets to P2 once again, and by the same time we will do the increments in C, and finally we will display what is C. The value of C gives us a cycle length. Am I right? Okay. So now from the next lecture we will continue with the another algorithms. Thank you so much.